Now we're asked for parts D, E, and F, we're asked for forces. So that means that the best course of action would be to draw a free body diagram. So if I was to redraw this surface and redraw this penny and draw in all the forces, I would know that I have a gravitational force, a normal force, and a radially inward frictional force. I don't have an applied force, but I do have a radially inward frictional force. So let's derive some equations. We know that Fn equals Fg. And we also know that our centripetal force is going to be equal to whatever in minus out. Remember, in minus out for circular motion problems. So our radially inward force is friction, our frictional force, minus our radially outward force, which we don't really have. So it's really Fc equals Ff. So in fact, if we do solve correctly for this problem, we can solve for both D and E, and I'll show you why. So the first thing, let's solve for our centripetal force, or and using these equations, let's solve for our centripetal force. We know that our centripetal force, if we know our equations correctly, is equal to mv squared over r. It's equal to mass times our velocity squared, our tangential velocity squared over r. So we can just plug in the values that we're given. We know that it has a mass of 2.5 grams, or is it kilograms? 2.5 grams. So grams, we know we can't really use grams. We have to use kilograms when it comes to physics. So we can, if you want to see the unit analysis, 2.5 grams to kilograms. We know 1 kilogram is 1,000 grams. So it's 2.5 divided by 1,000. So in fact, our mass is going to be 0.0025 kilograms. Okay, times our tangential velocity, which we've already found. And excuse me for not writing meters per second, but I don't want to use more time. And then our radius is 0.12 meters. We've already drew that out in our diagram. So now it just comes down to plugging in the correct points. So 0.0025 kilograms. So 0.0025 kilograms times 0.0656, or sorry, times 0.656 squared divided by 0.12. And we should get a centripetal force. And remember, we're given grams. We can only work with kilograms because kilograms and meters per second squared will cause this whole thing to be in newtons, right? So it's 2.5 divided by 1,000, multiply that value by 0.656 squared, and divided by 0.12 meters, and you should in fact get a centripetal force of 0.0089, or 89. I guess you can say 90. 90 newtons. All right, so that would be your centripetal force. So we solved for that. Now part E, we know we can already kind of solve for it, because we know from this equation, because this is a 0, so it's no value, we know that from this equation Fc equals Ff. So we know that whatever value we get for our centripetal force will be equal to our frictional force. So we pretty much solved for two things at once. We know that our centripetal force will be the same as our frictional force. So your frictional force will also equal 0.0090 newtons. So you really got two birds with one stone. So now, because you know your frictional force, and you know that your frictional force is nothing but mu times Fn, which you can simplify to mu times m times g, because of the fact that Fn equals Fg, and Fg, our gravitational force, is equal to mass times our gravitational acceleration. So I made a quick simplification there. So Ff equals mu mg. And we can use this value that we got for our force of friction, which is 0.0089 0.0090 newtons, and put that equivalent to this mu times m times g. So we will use our mass, 2.5 grams, but we have to use it in kilograms, so it's actually 0.0025 kilograms. We have and multiply that by 9.8. So you should get on this side 0.0245, and because it's kilograms times meters per second squared, it's newtons on this side. Divide both sides by 0.0245, and you should get 0.090 divided by 0.0245. You should get a mu value of 0.367, or I guess you can say 0.37 if you would like to. Your mu value, your coefficient of friction, is 0.37. Now, I'm not sure if I will have to make this a two-part video, so in fact, if I have to, I will stop it here, but because for me, this video is going on in one long continuous cycle, I will continue on with solving A and B. So we have to solve for our period. We have to solve for our period. So what is our period? Our period is the time it takes. So we know that our answer will be in seconds. So it's the time that it takes for one revolution. One revolution. Well, is there any other way that we can describe one revolution? One full, complete motion around this circle? Well, because we're in a circle, we know that one revolution is equivalent to its diameter, right? It's equivalent to its circumference, excuse me. One revolution is equivalent to the circle's circumference. So we can, in fact, simplify this or rewrite one revolution as the circumference of the circle, which we know circumference is equal to pi times diameter. So our circumference is equivalent to the diameter, which is 0.12 plus 0.12, which is 0.24. So it's 0.24 pi. And we want to know the time that it takes to travel 0.24 pi. So if I were to rewrite this, 0.24 pi, and we want to know the time that it takes to travel this distance. Okay? And that will be equivalent to our period. Well, does this equation remind you of any kinematic equation that we've seen before? This revolution is nothing but the distance around the whole circle, and we want to solve for time. So if we think back to our kinematics days, we know that distance over time is equal to velocity. So in fact, you can type in for your period, or for whatever this is equal to, you can type in, or you can plug in your velocity, 0.656 meters per second. And if you find the time that it takes to travel this distance, and you have your velocity, you know that it's going at a certain speed, that will be equivalent to your period. Okay, so this, if you solve for this t value, you will find your period. Okay, because t, your period, is the time that it takes for one revolution. So in fact, before when I wrote that this whole thing equals t, that's wrong. I'm sorry for writing that. This whole thing equals your velocity. But when you find your time, the time that it takes for it to go one revolution is equivalent to uppercase t, your period. So please excuse me for that little mistake, but if you find t, this t value, the time that it takes for one revolution, you will find your period, which is your uppercase t. So now it just comes down to doing the math, multiply both sides by t, and then divide it by 0.656. So you're doing 0.24 pi divided by 0.656, and you will get a t value of 1.15 seconds. So this t value, and I know it may be confusing, this lowercase t and uppercase t. This lowercase t, the time that it takes. Remember, your period is the time that it takes for one revolution. So your period has to be in seconds. So when you solve for time, you are really solving for uppercase T, because this is the time that it takes for it to travel one revolution, or one full circumference around this circle. Okay, so this time that you solved for is your period. And we'll use that knowledge, and please, if it lets me undo, so we did solve for our period. And we'll use that knowledge that we've ascertained to solve for our frequency. Remember, we know an equation. Our period is equal to 1 over our frequency. We have solved for our period. We know that our period is 1.15 seconds. And that is going to be equivalent to 1 over your frequency. So now it just comes down to solving for f. So multiply both sides by f. So 1.15 f. And I'm sorry, that's 1.15 f equals 1. Divide both sides. F equals 1 over 1.15. So a quick way, instead of doing all this algebra, you should know that your frequency is nothing but the inverse of your period. So if you have your period, which we've solved here, your frequency will be nothing but 1 over 1.15. It's just the reciprocal of this value, not the inverse. It's the reciprocal of your period. Okay, I showed all the algebra just to show where I got it from, but your frequency will always be the reciprocal of your period. So you didn't even have to do all this work. You could have just, because this period is 1.15 over 1, you could have just flipped it and done 1 over 1.15. All right, so you solved for your period, you solved for your frequency, and you have, in turn, solved the whole problem. Thank you for tuning into the video, and I hope you tune in for another one.